All right, so this chapter is nitrogen and sulfur, and you had a nitrogen and sulfur chapter in O levels as well. So a lot of things will be just a continuation of that. So I'll just go through with the syllabus. So the first thing that we know from O levels is that nitrogen is the major component of air. In dry air, does anybody recall what percentage of dry air is nitrogen?
78.
78%, yes. And it's a diatomic gas, N2, which is like this thing, and it has lone pairs on its side. Okay, so nitrogen has lone pairs like that, and it is a diatomic substance. It is very unreactive, and the reactivity is basically based on the idea that this bond, this triple bond, is very difficult to break. It has a high bond energy. So high bond energy of nitrogen-nitrogen bond makes it very difficult to break it. And that is why nitrogen doesn't really react unless there is high temperature. And there are two situations in which there is high temperature. First one is lightning strike. Whenever there is lightning, there is high temperature. So what happens is that nitrogen reacts with oxygen in the air and it converts because of that. Okay, so here's the thing. Nitrogen in presence of oxygen at a high temperature can break down, can react and make two NO, and NO is neutral. This is a neutral gas, which is a catalyst for uh, ozone depletion. And the reason for, I'll explain that at the end. And then this nitrogen monoxide can further react with oxygen, oxidize to make nitrogen dioxide, which is acidic. Okay, then there is another case where the same thing can happen, but that is man-made, and that is ICE. Does anybody recall from O levels what ICE was?
Internal combustion engine.
Very good, internal combustion engine. So internal combustion engines have high temperature, and that is where this same reaction can occur. But in this case, nitrogen and oxygen are again coming from air. In the exam, examiner might want to confuse you by saying that nitrogen in the fuel is doing this, but that's not the case. Now, plants need nitrogen, but because this bond is very difficult to break, plants cannot get nitrogen from the air. And instead, they have to rely on nitrogen ions, the ions that have nitrogen in them. And the very first one in them is nitrate. Nitrate is basically uh, a negative ion, anion, and it's a molecular ion, which means it's an ion made by covalent bonding. And obviously, the negative charge comes from having the uh, dative bond in there for some electron that has been taken away from something else. Uh, the nitrate ion, you can test it easily by adding NaOH, aluminum foil, and slightly heating it. And in that, what happens is that this nitrate gives us ammonia gas. And when that ammonia gas is taken out, you can test it by using a litmus paper, and that is an evidence that ammonia is a basic. Now, how is it ammonia basic? Now, does anybody recall what an acid was or what a base is? What's a Bronsted-Lowry definition of acid and base?
Acids were proton donors,
Acids give protons, yes, and
and a base accepts the proton.
very good. So that's a Bronsted-Lowry definition. Bronsted-Lowry, sorry. And what's Lewis definition for acid and base? It's very important. It's very important to remember this. Lewis says that base gives lone pair and acid accepts lone pair, which means that every time you have a dative bond, that's basically an acid-base reaction. So ammonia is a base based on both of those definitions. For example, if I were to add ammonia to an H positive thing, basically anything that's acidic, ammonia will accept this and form ammonium ion. Now, how does that happen? Basically, nitrogen, which has this structure, actually, it's not that. Using this lone pair, it's able to uh, make dative bond with the fourth hydrogen. So it forms a dative bond with the fourth hydrogen, and that is basically a hydrogen ion, giving this whole thing a positive ion. This thing can reverse, in which case ammonium will break down, give us ammonia and H positive. What does that mean? That means ammonium is acidic, and that is because if this is a base, this is the acid, then this is going to be the conjugate acid. Okay, and ammonium is acidic because it is able to give H positive away. All right, so you can form ammonium ion through an acid-base reaction where ammonia provides lone pair. So there's two reasons ammonia is lone pair. Ammonia is a base. One is it accepts H positive, and second because it has a lone pair that can donate. In fact, that lone pair is partly responsible for existence of proteins and obviously life as we know it. That lone pair in ammonia. So ammonia has played a very important role in existence of life when it comes to making of proteins, DNA, and other amino acids as well. The second, now ammonium, you can easily break it down into this part by heating it. But of course, because it's an acid, you can add a base to it. And if you add a base to ammonium, obviously it is going to give that H positive away, and that H positive will make water. So what's happening? Ammonium here is acid, and this is OH minus coming from base. So it forms a conjugate base and a conjugate acid. Okay. So it's again a neutralization reaction. And this ammonia is able to be given off, which basically means that if you take any basic substance and you add it to any ammonium substance, you're going to get ammonia gas. Why? Because the base will not react with the ammonia, but it will react the H positive. Similarly, if I were to add ammonia to an acid, ammonia will react and make ammonium. So it's a acid-base reaction either way. Uh, this is part of the reason that ammonium fertilizers and flaked lime shouldn't be added to soil, should not be added to soil concurrently, basically at the same time. Why? Because the slake lime, which is calcium hydroxide, after it reacts or on its own, it's just calcium oxide. That's a basic substance. It can provide OH when it reacts with water, and that OH can react with ammonium in the fertilizer and release ammonia. So instead of ammonia being dissolved into the soil, the nitrogen content is going to go up in the air in the form of ammonia vapors. So plants wouldn't get it. And when plants don't get it, it hinders their growth. So we need this to come out. What we don't need this to come out. We need the ammonium ions and nitrate ions to get to the soil and then be absorbed through the roots. Uh, this also means that if I have ammonium salt, then I can simply react it with any base and release ammonia. So any ammonium salts release ammonia when reacted with alkali. Okay, so that's again pretty straightforward. What's happening is that ammonium ion is giving H positive away, which is being accepted by an alkali, releasing ammonia in the process. If I were to react ammonium with an HCl, it wouldn't really react, but ammonia, if that was going to be formed, वो उससे react कर जाएगी. Okay, so that's the idea of ammonia and all that. Now, in the industry, we use Haber process to make ammonia. What do? We take nitrogen, we take hydrogen. This is something you've seen before. In a reversible process, we make ammonia. This process is called Haber process, and it is done at high temperature, even though it's exothermic. Why do we do it at high temperature if it's exothermic?
To increase the rate of reaction so that there are more successful collisions.
Very good, very good. So we basically increase the rate of reaction at the cost of a greater yield. So even though the equilibrium is going backwards or shifting to backward side, we still get a high rate. So we save time, and because time is money, it works. Similarly, we can use iron oxide or pure iron catalyst, and they work through adsorption. If you remember that this is a heterogeneous catalyst, and heterogeneous catalysts work through adsorption. Okay, so this iron or iron oxide will do that. We also keep high temperature, as I just said, and we also keep high pressure. We keep high pressure for a reason, coming from LCP. Does anybody recall what that was? क्यों हम high temperature रखते हैं? You have 4 moles of gas on the left side and 2 moles on the right side. So obviously there's a greater partial pressure on this side. So when you increase the pressure, these are the ones that are going to be colliding more because they have the greater partial pressure. And when they collide more, equilibrium goes forward. In O levels, we used to say the equilibrium goes to the side with less moles. Again, because the more moles react more, they go to the form the product which is on the less mole side. Then ammonia is highly soluble. Why do you think that is? So ammonia is highly soluble. Why would it be soluble? We just talked about it. Water can act as an acid and ammonia can react with it. So ammonia and water can react together and make ammonium plus OH. And that's why it's very soluble, which basically means that in presence of ammonia, we can make new precipitates. So, for example, ammonia in water makes ammonium hydroxide. And if I take any ion that reacts with it, copper, for example, so copper hydroxide will react and form copper hydroxide. So, copper will react and make copper hydroxide, which is a blue precipitate. Similarly, silver can do the same. Iron can form iron 2 hydroxide or iron 3 hydroxide, and they are also precipitates. This is green precipitate. कुछ याद आ रहा है O levels वाला? So this is all hydroxides being made for ions. So if you want to check if you have an ion present, all you got to do is add some ammonium hydroxide in there. And if there is a metal ion present, that will form hydroxide, and that hydroxide will form a precipitate in presence of ammonia. Of course, I'm talking to A2 people now, that copper, for example, over here, this has access to its d orbital. So what happens instead is then instead of having this copper hydroxide just as that, copper is also able to form this lone pair of nitrogen. It has the ability to form dative bond with copper. And when that happens, copper forms uh, this thing where you have different ammonia molecules joining this. Obviously, OH to hai wahan pe, but the four of them they join it, and that makes a complex which is soluble, which is why it gives us a dark blue solution. So in presence of ammonia, copper will form copper hydroxide, which is a pale blue precipitate. You can write pale or you can not write pale, it's up to you. But after you add ammonia in excess, so this is for few drops, and when you add it in excess, it's able to form this complex, and that complex basically makes a dark blue solution. So the complex is soluble in water again. Okay, so that is why copper used to in O levels, if you remember, copper will give you a blue precipitate which is soluble in excess of ammonia. That is because ammonia is able to form a complex with it, but not with iron or chromium and all that. Okay, so there you have it. Also, because ammonia has difference in electronegativity, this is a very polar substance, and that is why it has slightly high melting and boiling point compared to other hydrides of group 5, and that's because of its polarity. So it can form hydrogen bond. It is uh, it is soluble in water because of the same thing. It has relatively high melting and boiling point, and its ions can conduct electricity. Also, the shape is trigonal pyramidal, and it is a colorless gas with pungent smell. तो ये सारी बातें हमने O levels में पढ़ी हुई हैं. I'm just revising those for you. Okay. Now, does anyone know the shape of ammonia gas? Ammonia molecule. What would its shape be? It will be trigonal pyramidal. Okay. And what would be the shape of ammonium? Ammonium is like this. Have you seen this shape before?
Tetrahedral.
Tetrahedral, very good. So that means that when ammonia forms ammonium ion, its density decreases. Okay, so it has a positive charge as well. There are a few important products of nitrogen. उनमें हमने अमोनिया को देख लिया, नाइट्रिक एसिड है, उनमें नाइट्रेट्स हैं और उनमें नाइलॉन है. Okay, so those are the important products. यूट्रोफिकेशन एक इसका बाय प्रोडक्ट है, एक प्रोसेस है यूट्रोफिकेशन का. that you might remember from O levels. Charge steps थे उसके, क्या steps थे? So first one was nitrates, which are rich in nitrogen, leaching water bodies. What that means is that you have a high concentration of nitrates in there. This causes an algal bloom. Algal bloom क्या होता है? That there's a large increase in or rapid growth of algae. And what that does is that, first of all, it blocks off the sunlight. So there's no photosynthesis happening at the bottom. And secondly, uh, what happens is that blocks the sunlight and uses dissolved oxygen. So when sunlight is blocked, the plants in the water, they can't do photosynthesis. And when dissolved oxygen is used up, especially by the bacteria, so oxygen और ज़्यादा कम हो जाती है. So aquatic life sadly dies. So that is a eutrophication process, which is obviously bad for the environment. Then we have sulfur. यहाँ नाइट्रोजन में तो कोई मसला नहीं है ना, आसान सी बात है सारी, हमने बचपन में सारी देखी हुई है. Then we have sulfur. Sulfur is also really easy. You have a yellow solid, gives a very blue flame, slightly blue, नहीं proper blue ही होता है, blue flame, और बड़ा खूबसूरत सा होता है वो. Has a slightly high melting point, high तो नहीं कहेंगे, 120 होता है शायद, and it burns with a blue flame as I told you. सल्फर का सबसे important काम है कि सल्फर को बर्न करके सल्फर डाइऑक्साइड बनती है. This is very useful substance. क्यों? Because sulfur dioxide is acidic. It is used for many different purposes because of that. For example, it's used for sterilization of equipment. Okay? Because acidic, it will kill the bacteria. Same reason it is used in food preservation, because sulfur dioxide will kill the bacteria over there as well. Then sulfur dioxide bleaches wood pulp where we need it. We need it in paper industry. Again, something that we studied in O levels. But this sulfur dioxide does something else as well. So sulfur dioxide, in contact process, we reacted with oxygen to produce sulfur trioxide. Contact process is when you have 1 to 2 atmospheric pressure and you have high temperature, 400 बोल देते हैं, 450 बोल देते हैं. And here the catalyst is V2O5. This produces sulfur trioxide, and this sulfur trioxide, we use it to do two things. If I take sulfur trioxide and I dissolve it in water, it will produce H2SO4, and it will be explosive reaction, highly exothermic. So obviously nobody's going to go down that path. It can cause accidents. So what we do instead is a very unusual thing. We dissolve this in H2SO4, which is concentrated. Okay, now what that does is it causes it to form H2S2O7, just added to it. This thing is called oleum. In fact, oleum is ka fazul sa naam hai. Somebody was definitely being lazy when they called it oleum, because oleum simply means oil. Okay, if I had some oil coming from some random rocks, I was walking down a mountain, और rocks में से oil निकल आए, तो उसको मैं क्या बोलूँगा if I'm being lazy? I'll just call it rock oil. But if I speak Greek, then rock is Petra and oil is oleum. That's what petroleum is. It's literally rock oil. And this oleum is also just a dense thing, just like oil. तो इसलिए इसको H2S2O7 को oleum बोल देते हैं. It doesn't really have a name, proper name. And then this thing, H2S2O7, we add it to water, and interestingly, we were doing the same thing over here to get sulfuric acid, but this time water was very exothermic reaction. Water evaporate ho jata hai, you have drops of sulfuric acid all around that place, whatever you're doing. And obviously that's probably the last reaction you'll do if you try to do it yourself. But this time, it produces H2SO4 in large quantities. Very unusual. You're using H2SO4 and you're producing H2SO4, but double that amount. So what we do is we make some H2SO4 in controlled quantities. शुरू में लोग, मतलब every time I talk about this, somebody's like, तो शुरू में H2SO4 कैसे बनाया? भाई किसी और तरीके से बना लिया ना. There are many other ways of making it. And then we use it, and then we are able to multiply the amount. Okay. If we don't do that, we can also dissolve SO2 in water right away and get H2SO3. And this is called sulfurous acid. But I want you to call them by their other name. This thing is sulfurous because it is sulfur with a lower oxygen state. This is sulfur 4 acid. And this one is sulfur with completely oxidized situation, sulfur 6 acid. So can we convert sulfur 4 to sulfur 6? Of course, that is oxidation. So we can oxidize sulfur 4 acid to give sulfuric acid. Okay, which it does. If you just leave it out in the air, it's going to react with oxygen and make sulfuric acid. You give it an oxidizing agent और ज़्यादा हो जाएगा. अब इसका मतलब क्या है? If you have sulfur dioxide in the air, there might be rainwater, and that rainwater can react with sulfur dioxide and make sulfurous acid, but that can oxidize and form sulfuric acid. And there is a catalyst in the air which is really good at oxidizing sulfur trioxide. And that catalyst is nitrogen dioxide. We just talked about that. So अब क्या होगा? Nitrogen dioxide will react with sulfur dioxide and make sulfur trioxide. And that sulfur trioxide can react with water to produce sulfuric acid. Or ये rainwater है. So it is acid rain. But what about this thing? I said nitrogen dioxide is acidic, sorry, catalyst. So that thing can react with oxygen again and make NO2. So do you see how nitrogen dioxide is regenerated in this process? So it's an catalyst. So what should we do? ये सारी कहानी शुरू कहाँ से होती है? When you had nitrogen monoxide being made in your cars. See, nitrogen in the air, reacting with oxygen in the air, making NO, that NO making NO2, that NO2 oxidizing sulfur dioxide, which we really have not much control over because sulfur dioxide is produced in volcanic activity. Also, factories and factory owners usually don't like to be policed or given policies. So वो भी एक मसला है. But what we can do is that we can install catalytic converters. And those catalytic converters will take this nitrogen dioxide and react it with some carbon monoxide and give us carbon dioxide and nitrogen. And that's remarkable. What's happening here is that carbon dioxide is being oxidized and nitrogen dioxide is being reduced. Or even with nitrogen monoxide, they'll do the same thing. So you'll get carbon dioxide and nitrogen. And even in that case, what you're getting is remarkable because all we are doing is we are oxidizing one thing and reducing the other thing. So to oxidize one thing, we have one catalyst, and to reduce the other thing, we have another catalyst. There are three catalysts in total: rhodium, platinum, and palladium. Each of them doing completely different things at the same time with different molecules. So बहुत ही जबरदस्त chemistry चल रही होती है वहाँ पे in a catalytic converter, and that is how we get less harmful gases. Carbon dioxide, for all its global warming effect, it's still much safer than nitrogen monoxide, which will go make nitrogen dioxide, which will go make sulfur trioxide. Sulfur trioxide will dissolve in water and make acid rain. Not just that, sulfur dioxide can also react with this compound and make sulfur trioxide and oxygen. What is this compound? In fact, it's not a compound, it's an element. This is ozone, yes. So we have ozone in the upper atmosphere. So sulfur dioxide is double trouble. Not only does it deplete ozone, it also causes acid rain. So yeah, so problem is sulfur के साथ हम काम बहुत करते हैं, सल्फाइड ओर्स होते हैं, सल्फर के सल्फेट्स बनते हैं, सल्फेट से हम फर्टिलाइजर बनाते हैं, पेंट्स बनाते हैं, सल्फ्यूरिक एसिड बनाते हैं. Sulfuric acid is the most used chemical in the world after water. So we can't really get rid of sulfur. But what we can do is use it responsibly. So first of all, install catalytic converter in your cars so they don't produce nitrogen monoxide or dioxide, which catalyzes sulfur dioxide. एक तो वो हम कर लें, ठीक है, कर लिया. But again, what do we do about other production of sulfur dioxide? For example, factory में क्या करें? वहां पर तो सल्फर डाइऑक्साइड बन रही है. तो what we can do over there is that we can react it with a very cheap thing, because इंडस्ट्री वाले हमेशा पैसों की बात करते हैं कि बहुत ज्यादा महंगा हो रहा है ये एनवायरनमेंट का काम. So we have a really cheap thing which is calcium oxide or calcium carbonate. It's literally really really cheap, okay, dirt cheap. And you react this with the sulfur dioxide coming out, and what it does is it forms calcium silicate, which is a white off white solid, and you can just take that one and it will simply react. Okay, it will simply solidify and you can take that solid and obviously उसको उठा के बाहर फेंक दें या उसको properly dispose of करना बहुत आसान है compared to something going into the air. Similarly, over here, if I react it with calcium carbonate, what happens is that carbonate ion, remember that carbonate ion breaks down and produces carbon dioxide. So it forms carbon dioxide. So ये break down होता है, calcium oxide बनता है, carbon dioxide बनता है, and then वो breakdown होने के बाद carbonate breaks down, gives me calcium oxide and carbon dioxide, and obviously there's sulfur dioxide, which reacts with this again to give me calcium silicate. So whether I use calcium oxide or calcium carbonate, both of them, I will get sulfur dioxide reacting with it, making calcium silicate, which I can take out, and carbon dioxide, which is less harmful than sulfur dioxide, will go into the atmosphere. This process is called desulfurization of flue gas. Flue gas, basically the affluent जो बाहर निकल आता है gap. So calcium oxide or calcium carbonate, both of them react with sulfur dioxide, producing calcium silicate, and in the case of carbonate ion, I'll get carbon dioxide. And yep, that is how we can make sure that acid rain is reduced. We don't really get that much of acid rain because काफी नुकसानदेह चीज है. Okay, so nitrogen monoxide in itself is not dangerous, but it can make nitrogen dioxide, which is catalyst for sulfur dioxide, and that forms sulfur trioxide, and that sulfur trioxide dissolves in water to make acid rain. बहुत अजीब एक वो Pandora's box खुल जाता है if you don't have catalytic converter in your car, or if you don't have desulfurization process in the factories, or then it is very difficult to contain. Okay,